9A, Chapter 7 Review, Part 2. Alright, we are now going to find a solution to a system of linear equations by graphing. When we graph a system, we will get two lines that intersect. Where those lines intersect is the solution. Okay, we have in the past worked with slope-intercept form, y equals mx plus b. So that is what we're going to do right now. You will be given two equations. For example, x plus y equals 3. And negative 2x plus y equals negative 6. We're going to go ahead and change both of these equations so it looks like slope-intercept form. First equation, I'm going to subtract out the y, and you will have y is equal to negative x plus 3. Second equation, we're going to add out the 2x, and we would get y is equal to 2x minus 6. Right, here are the two equations that we are going to work with. Alright, so equation 1, let's go ahead and start graphing. Alright, the 3 is our y-intercept, so it's positive. It tells me I need to go to 3 on the y-axis and place a point. My slope, if you look in front of the x, there's that invisible 1. So my slope is negative 1, so that means I'm going to go down 1 to the right 1. Go back to where you plotted the 3. We're going to go down 1, right 1, and we're going to do this several times until we get ourselves enough points where we can draw a nice line. So let's go ahead and draw a line. Start here first, just so I can easily connect, and I'll extend it in this direction. Alright, so there is your first equation. Let's go ahead and do the second one. Second one we do in a similar, same fashion. Negative 6 is my y-intercept, so that means I'm going to go to negative 6 on my y-axis. My slope is positive 2, so that means I'm going to go up 2. Since it's over 1, we're going to go to the right 1. So let's do that a few times. Up 2, right 1. Up 2, right 1. And we're going to do this until I intersect the first line that I have drawn. Okay, so it looks like we have enough. Let's go ahead and do our line. So now if we look at where our two graphs intersect, I can go ahead and highlight that area, which is right here. So that means that the solution, the x and y values that will work for both of my equations and will give me a valid answer will be at this intersecting point. So to figure out what the ordered pair is, you first do the x move, then you do the y. So x means I am going to go ahead and move to the right 3, so my x value is 3. And from 3 you can see that I am not moving up and I am not moving down, so my y moves would be 0. So your solution to the equation would be 3, 0. Alright, next. Let's work on substitution. You will have a few problems on your test where you will have to use the substitution method. Substitution is easy when our coefficients are 1. Let's go ahead and take x plus y is equal to 2 go ahead and I'm going to look at my first equation here, and I can see x and y both have 1, so I can go ahead and either isolate the x or the y. It does not matter. I am partial to x's, so I'm going to go ahead and subtract out y to both sides. That's going to give me a new equation of x is equal to 2 minus y. I am now going to plug what I have for x into my second equation. This becomes negative 3 times x now is 2 minus y. Attack on the rest of my equation, minus 2y equals negative 8. Distribute that negative 3 to everything inside the parentheses. We get negative 6 plus 3y minus 2y equals negative 8. We need to now combine like terms. A negative 3y and a negative 2y is a y. Bring down your negative 6 equals negative 8. Still having to isolate this y. We have another transformation that needs to take place. We're going to go ahead and add out 6. Alright, so y is going to be equal to negative 2. You're halfway done. Take the value you've got for y, plug it back into one of your two original equations. Does not matter which one. I'm going to choose the easiest one, which was x plus y equals 2. We now know that y has the value of negative 2, so x plus a negative 2 is equal to 2. And remember, we're trying to move away from doing an addition to a negative. We want to write it as x minus 2 equals 2. Solve for x by adding out 2, and we find that x is equal to 4. Write your solution as 4, negative 2. X is always first, then y. You will have a few problems using the substitution method. Alright, next example, the combination method. Combination is where we change one or both of the equations so that we can isolate a variable and to solve for both systems. Alright, first equation, x plus y is equal to 6. Second equation, x plus 2y is equal to negative 8. Yes, we can use the substitution method to solve, but since they are teaching us a new concept in math, we're going to go ahead and use the combination method. So remember, with combination method, we're going to make sure our variables are all lined up in nice, neat columns. Next, we're going to see, okay, can I cancel anything right away? And it doesn't look like I can. Now, don't go assuming you can cancel these two x's right here, because we can't. They are both positive. We need a negative and a positive. I can cancel out the y's. It does not matter. You get to choose. Like I said earlier, I'm partial to the x's, so I'm going to go ahead and cancel out the x's, and I'm going to change one of my equations by multiplying a negative 1 to every term. What this is going to allow me to do is to cancel out the x's, because I will get a negative x and a positive x. So my first equation, once I multiply negative 1 to every term, would become negative x minus y equals a negative 6. And I'm just going to bring over the second equation, because remember, we want to keep everything nice and lined up. Alright, now you can see I have a negative x and I have a positive x, so I can go ahead and cancel those. That will give you 0. Negative y plus 2y is just 1y, and a negative 6 and a negative 8 is a negative 14. Half our work is done. Take y, plug it back into one of your two original equations, you choose, but I'm going to go for the easiest, which was x plus y equals 6. We now know y is negative 14, so x minus 14 equals 6. Add out 14, x is equal to 20. Okay, so now write your solution, 20, comma, negative 14, x first, then y. We can go back and check, plug these two values back into our original equations, and you will find that we have validated our solution. Alright, this is going to end part 2 of your chapter review. Look for